My name is Bard Rowan S. Benaventura, and this is the video sample and the explanation of how I made my image processing and filtering project. So in this video, I will be explaining how I made the GUI, how I made the code, and how the application functions. Due to obsolete use of the old way of creating the app, I will be using the new way in the MATLAB 2019 using the app designer. So after creating your graphical user interface or GUI, we will be creating functions. So the first function we will create is open image. So when we open the image, next is we need to get the file. So this gets the file and the path name of the file wherever in your PC. Then we use the function UI get file to allow us to select file from the browser. Next is we'll verify first if the file name is a valid file name. Next, we will get the full image. This function strcat combines the file name and the path name. Next is store the image to the variable by reading the image. So we read the image from graphics file. File name is the full path. Next, I like to store temporary image files so that it's easier to manipulate. So we will write the image, put file name temp.jpg. So that's temp JPEG, and we put the format to JPG. For output 1, I have temp1 and output 2 temp2. So this is just temporary, and these images will be deleted upon closing the application. After opening the file, we need to show using imShow. This is the display image, and we will display the original variable, then show it to output 1 and 2. Next is create a delete function. So this function will delete all the temporary images that we made. So we will do this for all the temporary. And finally, the new editor uses this to close the application. We use delete app. So this closes the application. We will add a function, a callback, and this callback will be a close request function. So when you close the application and you click the X, it will run this function. So delete temp. So when you close the application, it will delete all temporary files before properly closing the application. Okay, now we have all the upper portions of the application working. We will now go to the panel 1. So panel 1, we click on red. So RGB, add a function. Same thing with green and blue. This time, since RGB is usually used all together, so we will use a function right away. So RGB slider, we will make the function later. So we will just copy paste this on the other function. So what this does is when the value of this slider changes, it automatically runs the function. Then we go back to the top and create the RGB slider function. So we get the temporary image and then we manipulate the pixels in the image. This function in the image means select all rows and columns. So select all rows and columns, and this one is for the color. This one is red. So on every pixel, it gets the color of red. Every pixel in each row and column gets the color red. Then we will add the value of the slider. So this will make this will increase the color red on all the pixels. So we will do the same, but this time for green it's 2. So RGB. Blue is 3. Blue is light. Then we will save the image that we made. Next is saturation slider. So again, same thing, add the callback function. So we will have temp and read. So let's just copy paste. Then we will use the RGB to HSV. So this function converts the RGB image to hue, saturation, and value. Next is, again, just like in RGB, we'll get all rows and columns. Then HSV is hue, saturation, value. So we need saturation. So we use 2. Then add the value of the slider. So sometimes I don't like using variables. So we just remove that and put that there. Then to display the image, you need to convert it back to RGB. So temp is equal to HSV to RGB. After converting it back to RGB, we'll save. So this save function, as shown earlier, also displays the image. So it overwrites the image on whichever checkbox is enabled. Next, we have the hue. So in hue, here, add the callback function. Copy paste the saturation here. Then we will change this to 1. Then we're done. Next, we will do indexed image. We will use rounding of the value since I have encountered errors before of non-integer values when using the indexed function of MATLAB. Next, we will get the temp, then use the RGB to index function using the image temp and slider value, the rounded off slider value. And next we will save. So we will run the save temp function. Next is the binary image. So add the button, grayscale, add the button, and adjust contrast, add the button. So first is convert to binary image. Binary image only uses grayscale image. It encounters errors when you use RGB images. So we will first turn the image into a grayscale using RGB to gray. Then we will use the binarized image. Then we will save. Let's just copy paste. Now we will go to grayscale. So we already did grayscale. So let's just copy paste first the IM read, then RGB to gray, and then save. Then adjust contrast. So we will use the function image adjust. Same thing. The image adjust function only uses grayscale image. So it adjusts the contrast of the image based on highest and lowest intensity. Next, in this code, we will use the image filtering or image editing functions: sharpen, smoothen, and motion blur. So again, let's go for sharpen. First, again, we get the image. We will use the IM sharpen function. So this IM sharpen function uses the unsharpened mask to sharpen an image. Next, the smoothen image filter. So this smoothen uses image Gaussian filter. So it basically smoothens out the pixels of an image. The IM Gaussian filter use the smoothen slider value. Next is motion blur. So motion blur can be changed in a certain degree. So these two will run in conjunction with each other. We will use a separate function, motion blur, copy paste this here. Then on the top, we create a motion blur function. Then this time we will use a special function in image processing using F special. So the F special function allows you to customize the filter that you're going to use for your image. So this time we will use the motion, then value of the motion, then value of the degrees. So next we will apply the special filter using image filter. After that, we save. And then we are done. Now we will be showing you how the application functions. So the first thing that you will do is open an image. So first, let's open an image. So I will be selecting an image here. I chose RGB color spiral.jpg. So this spiral. Then once everything is loaded, you can choose from output 1 or output 2. So as I coded earlier, when I deselect this, automatically this will turn green and all the buttons are enabled. So now let's try changing the RGB values. Once you stop moving the slider and release the button, automatically it will apply. So this time you can use the slider for RGB altogether. Then you can click use as original. So this overrides all the temp image and use your output 1 as your original image. Next, we will open another image. So RGB color spiral again. Then we will show you how saturation works. Saturation removes the other colors in the color palette and turns everything just red or green or blue. So as you can see here, there's less distinction between the colors. Hue. So hue is just another term for color. So what this does is it adds RGB value to all pixels. So as you can see here, the color changes, and once the hue goes higher, it removes certain colors in the palette and turns them to black. Next, on the grayscale images, I will use this. So as you can see here, we have the image output. Once we click here, index image is just another way of creating a image map of each values inside a map. So as you can see here, the RGB turns into grayscale images, and this value determines how many types of in the grayscale will be applied. So if you use here, it turns black because it only uses a small amount of gray in the grayscale spectrum. So let's reset. Next is convert to binary image. So binary image turns the image into 1 and 0. So basically black or white. The RGB values is turned into either black or white depending on the intensity of each pixel. Next is grayscale. So grayscale is very simple. It just turns the image into a grayscale image. Here is an example of adjust contrast. In the MATLAB image processing toolbox, adjust contrast can only be used on grayscale images. So as you can see the difference, very high contrast between the darker and the lighter side of the color of the grayscale image. We will use another image for sharpen. To better demonstrate a sharp image, we will have a 3000 pixel image here. Then we will put it to the highest intensity. As you can see the difference of the sharper image, this portion is sharper than this portion. Next, we will smoothen. So here, let's increase the smoothen. So the smoothen, as you can see here, the pixels is very pronounced. But once you add a Gaussian filter using the smoothen, you will see all the pixels become more refined. Next is motion blur. So let's put motion blur at 50%. Then let's make it into 45 degrees. As you can see, the motion of the blur is now in a 45-degree angle. Now I will show you how to turn this RGB color spiral to add several layers of filters. So first, let's add RGB, for example. Then we use it as original. Next, let's add saturation. Then use it as original. Then we add hue, use it as original. Then sharpen the image, smoothen the image, and add motion blur. Then save. So that's how you add multiple filters to my image processing and filtering application.